Scriptarnica is a decentralized platform for reading and writing books, where a publisher can publish books without the publishing houses, and you can, as a reader, buy books, either the whole books or just the parts of the books which you want to read or you're interested in. Well, Scriptarnica is imagined as a decentralized system, which with it brings a lot of different problems you have to handle, and those are certainly the main things that we were focusing on. To solve the problems we have in Scriptarnica, we had to think of a couple of different domains for architecture. We had to solve the storage layer. We had to solve the encryption layer of that storage, so unauthorized access to the books wouldn't be possible. We also had to solve the distribution of books and how would you buy a book, and how does the platform enable it. And on top of all of that, we have to solve the issue of currency and how is value transferred across the platform. Scriptarnica stores books on IPFS, and we used IPFS because it has the structure of it is similar to how we are storing books. So we are storing books in a tree-like structure, where we would store a book, then its sections, then its chapters, then its pages, and so on. And that matches how IPFS stores its blocks, which makes it really efficient for our use case and is the most popular of the decentralized storage solutions so far. Because we want our buyers to be able to read either the whole book or a part of the book, we have to enable access to a subsection of the book as small as as possibly we can enable. And we solve that by using IPFS, as I mentioned, where we address each minimal section of the book, which could be a paragraph or a chapter, with the IPFS node, and we can associate a group of those chapters into a section which is also an IPFS node. So that way we can address any node anywhere in the structure, so from the whole book to the smallest part of the book, we can directly address it and download it that way. So because IPFS stores data as is, we have to first encrypt it before distributing it over IPFS. To do that, we are using the public encryption, and furthermore we are using the key derivation function, which is something that can be found in HD wallets, for example, which is a technique to derive child keys, descendant keys, from one single key, where we then encrypt the main book with a single key, and then do the same process which I described of how we lay out the book, the same thing we do with encryption keys. That way we can unlock the whole book with just one key, but we can also distribute any key down the line to the buyer without revealing the whole book. So another thing we wanted to solve is instead of handing out the book's own key to the buyers, we wanted to go a step further and protect the books even more by doing something that's called the re-encryption function, which is a technique to transfer a set of encrypted data from the owner's credentials to the recipient's credentials. So that would mean that when a buyer buys the book, he wouldn't be given the key of the book. We would pass the key of the book through the function along with the buyer's public key, and we would then transform that book which he bought into something that can be decrypted with the buyer's key only. So to recap, what we want to do is store books on IPFS and protect the books with public key encryption in combination with key derivation and proxy re-encryption, and manage the access and distribute the book using the platform, and manage the whole buying and selling process via our own cryptocurrency.